With the run up to Christmas, I don't have a lot of time, but I was looking through my phone and found some old footage. So we're revisiting the one mass and four mass drops. So we've got the one mass dropping at T velocity at four displacements, which would be 42 centimeters, and the four mass dropping at one velocity. Displacement 10.5 centimeters. So in terms of momentum, if we look, we've got the one mass at 2 velocity, so that equals 2, and the four mass at 1 velocity, that equals 4. So the fact is here that the four mass at 1 velocity has twice the momentum. You know, we've got to bear that in mind. That is a fact. But if we look in terms of energy, the half mv squared, we've got 0.5, which would be half of the one mass, times the velocity squared, which would be 4, and that gives us 2. And for the four mass, half the mass, which is 2. The velocity is 1, square 1, you get 1, so 2 times 1 is 2. So in terms of energy, these two are the same. So as before, when I did it with the zip tie on the marker on, the four mass does compress the spring under its own weight, roughly around 1 millimeter. So when we drop it, obviously we've got the energy of the impact plus that standing weight. So when we drop the one mass at twice the velocity, we should expect to see around about 1 millimeter less compression, because obviously that doesn't compress the spring under its own weight. So this is just a simple drop test onto a spring to collect the energy from the impact. You can't use a fucking spring in an experiment, they're fucking flawed. No, springs are fine. I think there's no problem there. I think you're talking shit. We need to ask an expert on this.
Talk about the fact that springs don't give back everything they're given, so they collect energy really well.
You see, I told you they were fine. We've confirmed it from the world's leading expert. I do apologise. Phew, I'm glad we cleared that up. Right, so springs aren't just good at collecting energy, they're really good. So we shouldn't have a problem with this experiment and these results, because we know springs in this respect, you know, in dropping on them and collecting energy, they are really, really good. So rather than having the zip tie on now, just put a bit of tape around the end and it's coming down. Takes out all the ball ache trial and errors because it's not hitting anything there. So here we can see everything's taped down, everything's fixed. We've got the 10.5 centimeter space room for the four mass. The camera's in a fixed position. The stand's in a fixed position. Nothing changes. Only the weights and the distances change. Full mass at one velocity. This has the 1 mil of extra compression, and as it's coming down, just zoomed in so we can see it a bit clearer. It's just about in line with that number 3. Right, so we've seen the full mass drop 1. What's next? We're now going to drop the one mass from 4 heights, going twice the speed. Okay, so, that'd be like half the momentum, wouldn't it? So we get half the compression? Well, not quite. We should get very similar compressions. What the fuck are you talking about? While they're different in momentum, they are equal in energy. Are you fucking pulling my fucking leg? What the fuck? Momentum is everything. Well, that's not strictly true. Shall we run the experiment and see? I gotta see this shit for myself. You gotta be fucking kidding me. Bull fucking shit. One mass at 2 velocity, and we predicted roughly about a mil less, so there we go. It's just about a mil above that 3 line, as predicted. Okay. You could have fucking knocked me down with a feather and bugging me fucking sideways. Holy shit, you're right. Yes, it's not intuitive, but there it is. Physics. It works.